Okay, so this is the Battleship AI code, Section 4, Group 5, Ben Lyons, Kevin Barisiak, Nick Dealey, Margaret Dioria. The overarching goal of our code is to have a Battleship game be fully playable, have a player choose an easy, medium, or difficult code to go against, and then have the AI perform at that difficulty level selected. And it should be very interactive, very easy to play the game. This is the main function of ours, play game, and it includes all of the other functions needed.
Touchscreen, just so you know.
It is a touchscreen, so I won't touch it again. But it will going through play game and incorporates all the other functions. So we'll take you through our main function, play game. We're still working on the GUI. We'll show you that at the end, but this is where we begin.
Okay, so like Marge said, this is our main function. This plays exactly one game, and it can be repeated many times. So the first thing we do is we initialize the attack board and the defense board to 0, just empty boards, right? Then we place the ships on the defense board using a function called place random ships, which I'm going to take you through right now. Place random ships, basically what it does, all right, is we do not have a valid ship placement, it randomly places ships. And the way that it randomly places ships is it goes through the board, okay, finds a square that the ship can be placed in, returns a list of those possible squares. That's what you see right here in generate ship placements. That returns a possible list of possible placements for the ship. Then it picks a random move from that list, makes that move on the board, and repeats for each ship. Once you go through every ship and have a valid ship placement for each ship, it then checks to make sure that that ship placement is valid, because there are some weird scenarios where it's not going to have a valid placement using this technique, and it loops until you get a valid placement. Then the next thing on the play game method is basically the play game method continues until no ships are remaining. So you have this loop, ships are remaining, okay? Generate a PDF for the ships and the attack board that you currently have. The PDF method that we're using right now is generate approximated PDF. We can also use generate Monte Carlo PDF, but generate approximated PDF is this function right here, which I'm not going to go all the way through because that would take too long. But basically, if you want a more in-depth description of this, you can take a look at our presentation and also some of the earlier deliverables that we've written. Then once you generate the PDF, you use the find best move function, which basically just finds the maximum value of the PDF. Then you take that move and you check if it's a hit and fire the shot on the board using our fire shot function. It's a pretty simple function. It also updates the ship placement so you know about ship health and all that. Then if the shot is a hit, then you go to the search and destroy function. And what this function does is it takes in the attack board and the ship placements as well as the original shot that was a hit, and it loops until that ship is destroyed. So it does a couple other things. For example, if while searching for the rest of the ship that you hit, if you encounter a new ship, it will go back and destroy that new ship too. But basically, this function is called whenever you fire shot and it's a hit, and it continues until all known ships have been destroyed. Then that's pretty much the end of our play move function. Play game function. The play game function returns the number of moves in the game as well as the end state of the attack board and the end state of the defense board. I have some test code here that I can run to show you what each function does. So I'm going to run that code, and it just ran. And let me open this up for you right here, and we're going to scroll up. Okay, so to test random ship placement, as you can see, this is a 10 by 10 matrix. Each of those numbers represents a different ship and ship size. This is a randomly generated board of 4 ships, 2 a size 3, 1 a size 4, 1 a size 5. Then here's our PDF generation the output of our PDF generation function. This first one is the approximated PDF method. As you can see, as expected, the higher numbers are in the center and the lower numbers are on the side. The Monte Carlo PDF function generates something that looks like this, which are bigger numbers, but as you can see, in general, the higher numbers are in the middle and the lower numbers are on the side and in the corners. There's a little bit of variance there because of just the random nature of the technique. Search and destroy. So this is a very simple example of our search and destroy, but basically what happened is the function, there was a ship that was found right here, so there was a shot fired there, and the function continued until it destroyed the rest of the ship. Then finally, the play game function. This is what the output of play game looks like. You have a defense board, which is where each ship was placed at the beginning. You have the attack board, where a -1 represents a miss, a 1 represents a hit, a 0 represents an unknown square. And if you look carefully, you can see that all of the ones at the end of the game correspond to the placements of the ships originally, and it returns the number of moves it took to play in a game. And now Nick Dealey will briefly talk about the GUI.
All right, so we have the basic layout of our GUI established. Right now we're still trying to figure out how we can make the player's offensive board function. So the way we want it to work is to you have the player come in after they have selected their difficulty, everything like that, and the game has already started. You'll have the player, when it is their turn, be able to take these sliders and select a position on the grid that they want to fire on to attack the computer. And once fire is pressed, that button, it'll check the coordinate that the player is undecided on and run that against check it against the AI's defensive board. And if it matches a ship placement on the AI's defensive board, it'll record it as a hit and let the player know, and then return a visual onto the board, which will be steadily being edited as the player makes their move. So if it's a hit, it'll come up and it'll show the entire board and what they've seen so far and where they've made hits and where they've made misses for each of the coordinates that they've put in, showing the board there.